Hi all, this is Pratik from TechieStop, and today in this video we'll be going through streams concept which is there in Java 8, which was introduced in Java 8. So it's a very important concept to know about, and it's really interesting as well to know how things work in streams. So yeah, let's get started. So I'll be walking you through this PPT which has different topics which we'll discuss through this entire video, and for each of the concept which we will be discussing we'll be going through the code examples as well, so to better understand that particular concept. Okay, so first, what is the properties of a stream? So everyone has a misconception that streams are also a data structure, but in reality it is not. So streams are not any other data structures, and it does not store any value. So in reality it doesn't store any value, rather it sources the elements from a data structure which can be operated upon through a pipeline of operations. So every stream is a sequence of operations which we perform on a particular data source, and that data source will be a data structure. Okay, and any change done through the stream pipeline doesn't affect the source of the stream. So you have a set of operations which are being performed on that particular data structure, which can be an array list or which can be a set. So if you perform any operations, so there will be an output of that stream after performing those operations, but the original source of that particular stream remains unaffected. So if you access that particular source after executing all those operations, you'll still have that source in its original state. Third one is intermediate operations like filtering are performed lazily on the source stream, which leads to an optimized processing. So there is a capability within the streams that so there are two type of operations we'll be discussing later. There are intermediate and terminal operations within streams. So the intermediate operations which we're talking about, like filtering, which we do, so that can be performed lazily. So lazily means that particular operation need not to be performed on all the elements which are present in that data source. So that will go through with a certain example as well later in this video. And lastly is elements of the streams are visited only once during the lifetime of the stream. So so when you perform any operations via a stream pipeline, so every element which is present in that data source will go through that the set of operations only once. So once though that pipeline is executed, and if you again try to access that stream and try to execute some of the operations on the same stream, you'll get an exception saying that the stream has already been processed. So either you reinitialize that stream with the data source, so that you can perform different set of operations again on the same stream. So those are the properties of the streams. Next we have a topic called stream creation. So there are certain ways through which we can create the streams. So let me go through it, and I'll switch to the IDE. So yeah, so I'm into IntelliJ IDE, so I'll be walking you through certain examples for each of the topic. So first one which we'll be going through is the stream creation. So there are certain methods through which we can create the streams. So say first one will be creating an empty sequential stream. So there are two types of streams. So one is sequential and one is parallel. We'll go through the parallel stream later in this video, but for now the method which is being used, it creates a sequential stream. Okay, so every operation on that stream is executed in a sequential order. Those operations cannot be performed in parallel. So that is the difference between the sequential and the parallel stream. So we create a stream with the static method stream.empty. And so let's say, so we have a function, I've declared a function called print stream values, which is declared here. It's a static method, and what it takes in is the stream name, just to identify which stream values have been printed, and then the stream object itself. So what it does is it executes a for each loop on that stream, and for each of the strings, each of the string present inside that inside that stream, that will be printed through the sysout, right? Then we have another example where we declare a array list. Okay, so we create an array list with 3 of these strings, string 1, string 2, and string 3, and we create a stream out of that array list. So that is being created using the stream method. Okay, so that stream gets created, and then we try to print the values within that stream with the same function. Okay, so I'll walk you through all the example first, and then we'll try to execute these this code and see what happens with every implementation, every stream creation which we are doing. Okay, the next one is the strings array. So it's another method, like if you have a string array, how to create a stream out of it. So we can have an arrays.stream function, which converts a string array into a stream. Okay, and then we use the same stream to print the stream values. Okay, we pass on the stream name, which is string stream3, which is same as the stream object and the stream object itself. Next one is we have a generate function as well. So within that stream class, so it generates the it has a supplier as a it has a supplier as a argument, which basically generates the values. So it is an infinite stream, you can say, because there is no limit applied to the stream, the number of items which will be generated through this supplier function. But in addition to that, in order to limit the number of elements which are present in the stream, we can apply the limit function. So this limit function basically limits the number of elements to 10, and then we try to print all the values present in that stream. And last one is the iterate function. So we execute the iterate function on the stream subject stream class, and so which basically takes in the seed value, which is the initial value, and then a function. So basically this function gets applied repeatedly on the first on the seed value, and then all the generated values. So it gets applied repeatedly, and there is a limit to it, which is 20, so that we have some finite stream being created, not the infinite one, and then we try to print it. Okay, so let's execute it. Okay, let me do one thing. I'll restart it, because there might be an issue with the cache. Let me restart it, because there might be some issue with the data being cached in the IntelliJ. Okay, so now let's try to run it again. This seems to be an issue again. Okay, now I think it should work. Yeah, so if you see here, for the first example, if we are trying to print the stream's value, which is an empty stream, it doesn't print anything. It doesn't have any elements present in that stream. Then for the second example, we had the array list containing 3 strings, and when we try to print these values, okay, so this is the example which I'm talking about. So we try to print the values within that stream. So it prints string 1, string 2 and string 3. Then we have the string array, so it also creates a stream out of it, and it prints the values present in that stream, which is ABC. And then what we have is this generate method, which basically generates the items, the item string. It's an infinite stream, but we have limited to 10. Okay, so ideally it should contain, this stream should contain, once printed, it should print the item value 10 times. So this is what it has done. Okay, and the last one is the iterate function, which basically starts with 20, and repeatedly this function, which is n equal to n plus 1, like we are adding 1 to the value every time that function gets executed. So every time we add 1 to it, it is being it is generating a new value by adding 1 to the previous value, and we are limiting it to 20. Okay, so this is how the iterate function works, and these are certain ways through which we can create our streams. Okay, let's move to the next topic. Next topic is referencing a stream. So this is how we reference a stream. Okay, this is the same example which I'll be walking you through. So let's switch to the ID. Okay, so I have all the examples within the same file, so I'll just comment this one. Okay, and let's uncomment the second part of this video, which is referencing a stream. Okay. So similarly, so how do we refer a stream? So it's basically we have seen this in the previous example as well. So we are creating an array list, and from that array list we are creating a stream. And this is certain examples of the operations which we can perform in the stream, so which will go through in depth later in this video. But for now, just consider it as an intermediate function called filter, which filters out the elements which are present in that stream based on certain criteria. So it takes in a predicate function, which is a type of a functional interface wherein which takes in some value and generate true or false based on certain conditions. So what it is checking is if say the input string from that stream, if it contains str, which is in lowercase, then it should filter those strings, but filter out those strings which doesn't contain this string inside it. Okay, and then there's a terminal operation. So basically there are two types of operations, intermediate and terminate. And terminate basically terminates your stream, and find first is a function which basically returns you the first element within that stream. And so this stream is basically a stream which has filtered out all those strings which doesn't contain this string inside it, and this function will return the first string out of that. So we'll see what result we'll get. And second thing which I discussed earlier in this video, that a stream once referenced should not be referenced again. So all the elements inside that stream should be processed only once. So if say the same stream which we have processed through this terminal operation and this intermediate operation, so if we try to access this stream and try to execute any of the function, which is find any in this case, so we should be getting an illegal state exception inside it. So Okay, let's run this. Okay, so yeah, so if you see here, first is the optional result which we see here. So there are three strings, which is string 1, string 2 and string 3, and this filter basically is satisfied by these two strings, string 1 and string 3. But the terminal operation what we have here is the find first, so basically which returns the first string which satisfies this filter condition, and that is what we get in the result variable, which is an optional variable in our case. Okay, and the second statement which we were talking about, like, so since the stream has already been operated upon or closed, we can't execute any operation again on that particular stream. So what I do is I reinitialize it with the same state same function. Okay, then I think we should not be getting this this exception. But since we are not reinitializing it and we are simply using it and executing another terminal operation on that stream, so we are getting this illegal state exception. So let's try it again. So if you see here, find any doesn't return anything, and I think, oh sorry, I apologies, so I didn't print out the result here. So let me print it again. Right, so this is string 1 because it is the first one, and the find any is something you can get string 3 as well, because it is upon the function to return any of the string values which satisfy this filter condition. Right, so this is how we refer this stream, and there is a point which you have to keep in mind while using the stream is that once the streams have been executed, you can't use the same stream object again and execute any of the terminal operation on it until unless it is being reinitialized with the with some other data source. Right, let's move to the next topic then. Then we have stream pipeline. So yeah, one of the example which you have already seen, that there are certain operations which perform on the data source. So a stream pipeline basically consists of three parts, which is the source, intermediate operation and the terminal operation. Okay, so source is your data source, like the array list or the string array as we saw in the previous examples, and the intermediate operations what we saw are, say, filter operation or the map operation. There are certain intermediate operations which are there in the stream class, and then we have the terminal operation, which basically terminates your stream pipeline. And so there is a point to be noted that until unless you have a stream with a terminal operation, your stream would not be executed. So you need to have the terminal operation present in that pipeline, so that once you execute that stream, you will get some kind of result from that stream processing. Right, so this is one of the example here. So we have an array list which is having string 1, string 2 and string 3, and so yeah, this is the same example which we saw earlier, that we have a filter here which says that only filter those strings which doesn't contain or which contains str inside its value. And then what we are doing is we are performing certain other operations, like we are skipping the values, we are mapping it to something else, we are sorting it, and then ultimately we are counting all those elements inside the particular stream. So this is one of the example of the stream pipeline. We will be going through other examples as well in this video. So we have intermediate operations like map, filter, skip, sorted, peak, and distinct. We'll go through some of these operations with the examples as well. Then we have terminal operations like collect, count, sum, max, find first, find any, for each, and reduce. Okay, let me switch to the IDE. So in order to go through the examples, code examples. Okay. So I'll comment this out. Okay, so let's move to the another section, which is upon the intermediate and the terminal operation. Okay, so let me walk you through all the examples first, and then we'll execute it and see what it generates. So first example is me see, it is giving me one error here. Okay, I think there is one. Right. So first example we have here is the list, array list containing 3 strings inside it, string 1, string 2, and string 3. Then what we're doing is we are creating a stream out of that array list, and we are performing an intermediate operation which is called map. What map does is it takes in the string values and convert it into some other value by doing some operation. So say what it is doing is it is adding the space value to all the string values which are present in that stream. Okay, and then we are using the same function to print the stream values. The second example we have is the int stream. So this is also a class which represents the primitive int valued elements. Okay, it creates a sequence of those elements, only the int values. So we have other classes as well, like double stream or the other primitive data types related classes as well. So this is one is for the int data type, and what we're doing is we are creating a stream out of it using the int stream dot range. So range function basically generates a stream, and it starts from 0 and this to and generates the elements till 20, and this is the exclusive value. Means it is not included in the list of elements which gets generated, so it generates the values from 0 to 19. And then we are forming another operation which is skip. So we are skipping first 5 elements from that tree. Okay, so you'll not see 0 1 2 3 4 when we try to print these values. So when we are trying to print these values, we'll see all these values after the first 5 elements have been skipped from this tree. Right? Another example is of the peak function, which is also an intermediate function which is used to print the values as they are being processed through the streams. Okay, so we are creating a stream using the range method, which generates the stream starting from 4 till 10, but 10 is not included, so it will generate the stream of elements containing 4 5 6 7 8 and 9. Then we have peak function, which basically prints all those values which are being processed through this pipeline, and then what we are doing is it's a terminal operation which is sum, and it basically sums up all the values which are being included in the stream. So and then we will print the sum, right? Then the next example is of the sorting, and not of sorting but of the max, right? So we have an array list, and what we're doing is we are trying to find the max out of these values, and we're printing the max value. And the last one is of the distinct. So basically if you want only the distinct elements which are present in the stream, present in the list, you can just create a stream out of this array list and print the and execute this string distinct function, which will only create the stream containing only the distinct elements present inside that array list. Okay, so let us execute this code. Okay, so if you see for the first example what we saw here, so we saw that a map function being used which adds up some values to the incoming string values. So it basically converts it into string 1 and space value, string 2 space value, and string 3 space value. Second example was of the int string, which generates an elements from 0 to 19, but it also skips the first 5 values. So basically, so when we try to print this stream, we are getting the stream starting from 5. So 0 to 4 have been skipped. Then the next example was of the peak and the sum. So peak basically prints out the elements which are being processed through this stream. So we are printing the values here, so which is 4, 5, 6, 7, 8 and 9, and ultimately what we are doing is we are summing up all these values, so it will print the sum of these values, which is 39, right? Then we have a example of max. So basically max is the maximum value out of these elements, which is 10 here. So we are printing an optional value which is 10. Then we have a distinct example. So basically we have an array list containing repeated values of 5 and 9, but when we apply this distinct method, it basically removes those duplicate elements and print only the distinct elements present in that list, right? So this is some of the examples of the intermediate as well as the terminal operations. So there are other operations as well, like reduce and collect, which will go later in this video, right? Let me switch to the slideshow. The next topic is the lazy invocation. So intermediate operations are lazy, that is they will be called only if required for the terminal operation. So yeah, this is what I talked about in the properties section of the stream, that all the intermediate operations are not called for every element present in the data source. So it basically depends, like based on the pipeline which you have created, whether a particular intermediate operation have to be executed or not. So let me go through an example once. Let me comment this part and move to the next part. This is for the lazy invocation. So here what we are doing is we are having an array list of string 1, 2 and 3. Okay, and then we have created a stream pipeline, which is, so we convert an array list into a stream. We are filtering all those values based on whether this element contains 2 or not, contains a substring 2 in it, and then we are mapping it to, say, we are converting into uppercase, and finally what we're doing is we are trying to find the first element out of that string, right? So let us print this stream as well. right? Okay, so we don't require it to be printed. Let's see what it prints, because we have some print statement inside the intermediate operations as well. So let's see how it works. Okay, so this is what is printed here. So we have a filter operation which also prints the filter method, this filter statement. Filter was called for which element it is trying to process. So it prints two values, string 1 and string 2. Okay, and then we have a map element which is being executed only for string 2, right? So how it is done? So because this filter operation is being, and there is no print statement for the string 3. So how the processing is done is, so string 1 is the first element which gets operated through this pipeline, and so filter method acts on it, but this condition is not being satisfied by this first element. So the map method is not being invoked for the string string. And then we have next element, which is string 2 with an S in caps. So it satisfies this filter condition, so it moves to the next operation, which is map, and it gets converted into uppercase, right? So map is being called for the string 2 as well. The string 2 is filter method is also called, and the map method is also called for the string 2 string. And then we have the last element, which is string 3. So the filter method, so since the find first terminal operation, it needs to find only the first element present in that stream which satisfies the filter condition as well as the map condition, so filter condition. So what we are doing is, since it has found this string 2 value, so if I just print since it is not a stream, we'll just say stream first. Okay. Let me run it again. So if you see, only the string 2 gets printed, and the string 3, since it has find the first element, it doesn't need to operate upon string 3. So string 3 will not be operated upon through this pipeline. So this is how lazy invocation works. So whichever number of elements are required to execute this particular pipeline, only those many elements will be operated upon. The rest of the elements will be skipped. Okay. So this is how lazy invocation works, and it basically improves your performance because you don't have to operate upon all the elements present inside the data source. Right. Okay. Let's move to the next topic then, which is order of execution. So the intermediate operation which reduces the size of the stream should be executed first. So if you see in this example, we have, say, an array list we are converting into a stream, and first we are skipping 2 elements, and then we are mapping it to something else, and then we are ultimately counting the number of elements. So the skip operation, if say we do the map operation before the skip operation, so in that case all the elements present in that list have to be executed through this map operation, and then we'll be skipping the 2 elements, and then we are counting it. So if say you don't need those 2 elements in your count, then you can simply skip them first and then execute the map element, right? So this is how the order of execution works. So you have to decide upon what type of stages, like the order in which you have to execute your pipeline. So you can decide and optimize the way you are executing your stream pipeline, right? Then we have reduce and collect methods. So these are also type of the terminal operations. So basically reduce is a method which basically reduces the stream of elements into a single value, and collect method basically collects all the elements which are present in that stream. Ultimately it collects it into a particular data structure, right? So let us go through some of the examples here. I'll comment this part now. So this is what we saw, the order of execution. So similarly, if I execute it, the size will be 1, right? We are skipping 2, so size will be 1. But this map method, so if I put a peak function here, right, which is string, and just print out the right. If I don't print this size, I just print these the strings which are getting operated upon. So in this case only string 3 gets operated. But if I swap the positions of this map function, and try to execute this, so ultimately I think let's print the size as well. So earlier we were getting size as 1, so we get size as 1 also in this case, but we have to operate upon all the strings which are present in that list. So the number of elements, number of strings which gets operated upon, it increases based on the positioning of the intermediate operations which you are executing. So you have to decide, in order to optimize the pipeline execution, you have to decide the placement of the intermediate operations as well, right? So let's comment this, and let's move to the next which is reduce and collect. Okay, so here what we are doing is we have an array list, we're converting into a stream, and we are applying a reduce method, which is a terminal operation. So what it is doing is, it is basically means taking in two elements at a time and adding those values. So basically it is similar to the sum operation, but we are reducing it to a single value through a reduce method by summing up all the values which are present in this list. Okay, then we have collect method example, wherein there is a list, we convert it into a stream, and we then collect all those elements but while collecting we are averaging we are calculating the average of all these three elements present in that list, and printing that average value, right? So while collecting, we can perform any operations on it. We can collect it into a list, or we can create a we can operate upon those values, and in this same way we are doing it in this example, that we are calculating the average of all the elements present in that list. The next example is say an array list is there of strings, and we create a stream out of it, and when we execute the collect method on it, what we are doing is we are joining all those strings, and so we have three arguments being passed to this joining method, which is a delimiter. So while combining all these strings, what delimiter which we have to specify, what delimiter which we have to use, what is the prefix and what is the suffix, okay, and we'll see, let us see what these three implementation does. So for the first one, it has added all these values. For the second one, it has created the average. It has generated the average of all these values. And last is the so while combining those strings with the prefix and suffix and the delimiter, it has generated a combined string out of those strings. So this is a few of the examples for the reduce and the collect method, right? Then we have parallel string. So as of now, we have been performing operations on a sequential stream, like on a single thread itself. Your stream of operations gets executed in a sequential manner, one by one after the another. So that will not take advantage of the multiple CPU cores so that your processing becomes faster. But if say you want to take advantage of that, then you can use parallel streams. And for creating parallel streams, we have a method present which is say dot parallel stream or dot parallel, and we can also check whether a particular stream is parallel or not through the is parallel method. And when we execute any pipeline, so then those operations are being performed in parallel, like it creates a subset of the input source elements, and for each subset it performs all those pipeline operations on that subset, and the result of all these subsets are then combined to generate the final result. So this way means creating the subset of the data source and then combining all those roles, that is the extra overhead which we incur while executing the parallel streams, but it ultimately it gives you that performance benefit, so that your entire stream operation, the final results, get generated faster than the sequential streams, right? So let's go through the example. So this will be the last example for this video. And yeah, we have the flat map as well, so we'll go through that as well. That is not there in the PPT, but I have one example present with me. So this is how the parallel stream works. So let's comment this part. So we are creating that in integer stream and with this range method, and we are converting into a parallel stream through this parallel function invocation, right? So it returns an equivalent stream that is parallel, and we can check that as well, that whether this stream is parallel or not through the is parallel method, and we can thus print out these boolean variables, and we can execute a sum operation on this parallel stream. So let's execute it. Okay, so it returns true since we have created a parallel stream out of it, and it just calculates the sum, right? So one last example is for this video would be on the flat map. So but that topic is not there in the PPT, but I'll go through it quickly. So flat map is basically it converts the stream of streams into a single stream. So in this example, as you see, what we're doing is we are reading a file which is there inside the resources folder. So I have placed one file here in the resources folder which has this content inside it, and so what we are doing is we are reading the lines out of that file. So we have a stream of strings, right? But the line itself is also a you can say a collection of words. So what we are doing is we are executing a flat map function on this stream because it is a stream of streams. So lines, there are multiple number of lines, but within each line there are multiple words as well which are present. So you can consider it as a stream of streams. So lines dot flat map. So what we are doing is for every line we are creating a stream out of it, so that by splitting this line with the spaces, so that every word so we have a stream of words which gets generated from this line, and then this stream of words we have, so we'll print all those stream of words through this same function print stream values. See, so it prints all those words, right? All those words inside it for every line, right? So we are flattening out all the stream of streams into a single stream, so that this word stream will have all the words present in that file, right? So that's it from the streams concept. So let me know through the comments if you like the video or not, and any suggestions if you want me to improve upon. Okay, thank you for watching the video. Bye.